In this video, we want to look at the counterpart of t-test, counterpart of one sample t-test, which is two sample t-test. Assume we have marks of students on the same subject, two groups of students. We want to monitor if their performance is different. So we'll have scores in terms of mark A in a group and other scores in terms of mark B in another group. So basically, we're interested in looking at the difference between mark A and mark B. And if there will be a difference, then that means that we have a perfect kind of conclusion to say that the scores of students maybe in B were significantly higher than the scores of students in A. Or we can simply just conclude that the scores are different. So how are we going to do this? How are we going to organize our data set? Then what are some of the preliminary tests that you're going to run to allow us now to proceed with the two sample t-test finally? Well, let's have a look at how we're preparing our data set. We'll simply have them in two vectors, mark A, mark B, convert them into a data frame with the groups in one column and the marks in the other column. So then after that, there's something that we also take into consideration in terms of counts of the marks. Two sample t-test allows you to have different count of values for the two different groups. Well, in this case, we do not have the different counts, but just to highlight that it allows you to have such a difference, and we can as well include it here. Well, having seen that we have the mean for mark A as 62.1 and the mean for mark B, which are two groups of students, as 52.8, then now we want to run a statistical test that will confirm to us that the marks are really different. So then, before we proceed to how we're going to set our null and alternative hypothesis, let's plot a simple box plot by the help of ggpub-r package, and let's see how it is. Well, as our box plot is coming up, okay, let's have a look at it. You can see mark A and mark B. We can admit that mark B is slightly lower than mark A. So these two groups of students performed differently from a far point of look graphically. There's an outlier for mark A. We are yet to confirm this by a statistical test, which is two sample t-test. These are totally two groups. So then, how are we going to confirm this? We want to confirm they're different. Then after that, we want to confirm how different are they? Is mark A higher than mark B, or is mark B higher than mark A? Let's have a look at how we'll set the hypothesis. So when you look at these, the null and the alternative, you'll see the plain hypothesis, we have mean of A to be equal to mean of B as our null. Then our alternative for that particular case would be mean of A not equal to mean of B. So if we're going to run our test, then we find the p-value to be less than 0.05, then it means we're going to reject our null. Then what will our conclusion be? We'll conclude the alternative, that the mean, or actually these two marks, are totally different. Well, now to construct a more clearer picture, then to now know whether mark A is higher than mark B, we define the hypothesis even more by having the less than and the greater than symbols for the hypothesis. So look at hypothesis 2. This is testing whether mean A is greater than mean B. Then another one is testing whether mean A is less than mean B. So you find that hypothesis, the plain hypothesis for the difference, that is called a two-tailed test. But for the two whereby we are testing whether mark A is greater than mark B or the vice versa, that is a one-tailed test. Well, leave that one alone. We now have a clear picture of how we will construct our hypothesis for our test. We have now constructed it, and this is it. So before we proceed to doing our statistical test for this case, which is two-sample t-test, then we have some preliminary tests that we have to run before we confirm that now we have a go-ahead to now proceed to running our t-test. What are some of them? The first preliminary test will be to seek to understand whether two of our data set are actually normally distributed. What will be the null and the alternative hypothesis for that case? Our null will be that our data may be A or B is normally distributed. Our alternative will as well be that either mark A or mark B is not normally distributed. So what does that one mean now? If at all our p-value will be less than 0.05, we will actually conclude our alternative that they're not normally distributed. And that one means we're not going to go ahead to conduct our test. So let's rush and see what is the case for this. You can see that mark A is actually normally distributed. We do not have sufficient evidence to reject our null that the data is normally distributed. This one gives us a go-ahead to now conduct a t-test on mark A. Because we want to conduct a two-sample t-test, then we have to run again a normality test for the mark B. And the test we're using in this case is Shapiro-Wilk test for normality. Well, what does mark B gives us? You can see the p-value is at around 0.93. That one means that we again fail to reject our null. We do not have sufficient evidence. So that one confirms to us that both mark A and B are normally distributed. So we have a clear go-ahead to now conduct our t-test. But we have another preliminary test that we have to run. That is homogeneity test or variance. We want to confirm that the variation between the two data sets are actually the same. So that one will give us a comfortable point to now run a t-test, which actually looks at the mean more than any other thing. So if at all we have a wide variation in maybe mark B and a small variation in mark A, then t-test won't be really reliable. Well, let's conduct the variable test, the var.test on this, and let's see on how it is. But before we proceed to that, let's look at its null and alternative. Its null goes as follows, that the variance is same in each population. What are some of the population? Mark A, mark B. Okay, look at the alternative hypothesis. That the variance is the same, is not the same now. Yeah, is not the same in each population. So now to run this test on mark, we have the p-value not meeting our threshold for null rejection. So now we can comfortably confirm that the variance in each of the two populations is the same. These two preliminary tests, normality and homogeneity variance test, confirms to us that they've met the threshold to run our t-test. So now we are comfortable to go ahead and run our t-test. Now, how do we run our t-test? Assume our data set was different or lengthy. This would work. Assume it is the same as of this case. This will work. Then now our t-test according to the hypothesis that was set here. What are we getting? We have our p-value to be not less than 0.05. That one tells us that we do not have sufficient evidence to reject our null. So this one confirms to us that the scores for class A and class B in this particular subject is more or less the same. We do not have sufficient evidence to conclude that the scores were different. So that is how to run a two-sample t-test. Alternatively, this is another approach that we can run it, but this now calls it from the data frame. The first approach calls it from the vector point. Well, this is how to do it. The same practice script is attached, and its link to download the script is the description section of this video. Find it, download it, and paste practice. So let's meet in the next video. Thank you.